the function I drew. Okay, it's not exactly the same, but it's pretty close to just a standard parabola, right? So a parabola has the equation f of x is equal to x squared, right? That would be a parabola. Okay. So how can I take this idea here, and what would it mean if this was the particular function f that I was looking at? Oh, okay. Well, he would say, look, the gradient, which is not just a number, it's a function, it's changing, okay, is equal to this thing as h gets really tiny. Okay? So instead of f's here, I can actually put in, well, this is what f is. Okay? So instead of f of x plus h, I'd say x plus h all squared. You see, I'm putting x plus h into my function. Okay? Minus f of x, which is just x squared. There's my rise. Okay? And then I want to put in the run, which is just h. Okay? That's how far I'm going to go at any given point. Okay? Now that doesn't look very helpful. Okay? So can I do anything with this to make it simpler? Well, up here, I can actually, you can work with this algebra. You can work with this algebra, right? When you expand this thing out, what do you get? What do you get? I've got an x squared first, then I've got twice the product of the two things, and then I've got an h squared. Okay? There's the first part, and then I've got an x squared on the end. All of this is divided by h. Okay? Now you can see I've got some cancellation happening, right? This guy and this guy will cancel, which will leave me with 2xh and h squared. Okay? But at this point I've got a common factor. Everything's got an h in it. Okay? So I'm going to divide through. Okay, now you look at this. And because I've gotten rid of my fraction, okay, I can now actually do some logic with this and say, well look, as h approaches 0, what does 2x plus h approach? What does it actually become? Well, the h just vanishes off. It just disappears, right? So I can actually substitute in h equals 0. I couldn't do it before, because it was on the denominator, but can now, right? So now that's just equal to 2x. The h has become insignificant, okay, or trivial. Okay. Now what does this mean? What is this about? What statements can we make on the basis of this? Okay. This is telling us our gradient, right? We're used to saying the gradient of this line is 1, or 3/4, or minus 5. Okay. But now the gradient has an x in it. It's a function. It's changing. What does this mean? Well, let's think about what x squared actually looks like. And I'm going to get you guys to draw with me just a really small table, okay, which has x squared, the function, x, and 2x. Okay? So this corresponds to f of x and f dash x. Okay? So let's put this together in the table. Pick a value, any value. Let's take one like, say, 6. Sure. There's 6. Okay? So when x is equal to 6, what's f of x? It's 36. Okay? So it's quite high up. What's f dash x? This gradient function here. Okay? Well, it'll be 2 times 6, which is 12. What does that mean? What's a gradient of 12? That's super steep, right? Which is exactly what you expect over here when x equals 6. Okay? Let's pick a number that's closer to home. Like, say, 0. Okay? When x equals 0. I'm at the origin. Right? X squared is equal to 0 as well. 2x is also equal to 0. What does that mean? What does a line with gradient 0 look like? It's a horizontal line, which is exactly what you see here. If I zoomed in, if I took a picture, okay, of that spot there, sure enough, actually even this box, it looks like a horizontal line, almost, doesn't it? Positive, 0. Let's take a number over the other side, like say over here. If that's 6, I guess that's like minus 3 or something. Okay? At minus 3, what's the function equal to? It's equal to 9, because I square it. I'm up there, sure enough. What's 2 times x? The gradient function. It's minus 6. What does that mean? It means when a gradient is negative, I'm decreasing, which is exactly what you expect over here. Okay? So, this idea, right, and with a simple example, is so crucial, and it forms the basis of everything else that we're going to look at in this topic, right? Which this is where we started, right? They call this first principles. Okay? It's a way to work just from the basic definition of what is gradient, okay? And therefore, how can I find the gradient function? If gradient is just rise over run, that's what this is, okay? And I'm taking it when you've got a very, very infinitesimally small gap between the points that are rising and running.